How to find a wormhole. Wormholes are a handy device for science fiction writers as they allow humans and their spaceships to travel vast distances across the universe in a matter of minutes. In the time it takes for a single plot point to develop, fictional beings can hop from star to star, from galaxy to galaxy, skipping light years of voidal nothingness in the process. But what is the truth about wormholes? Are they entirely fictional, or might they really exist? And if these time-bending objects are out there, how might we go about discovering them? Let's find out now as we explore how to find a wormhole. There are two types of wormhole. One is entirely theoretical and is hypothesized to exist in space, and the other exists at the back end of an invertebrate. Probably. I admit it. I have not researched the digestive processes of worms for the purposes of this joke. The hypothetical wormhole was first conceived of in 1916 by Austrian physicist Ludwig Flamm. Flamm came up with the idea while he was studying Einstein's theory of general relativity, specifically during his research into a solution to Einstein's field equations written by German physicist Karl Schwarzschild. Schwarzschild's work described the gravitational field present around a spherical object of mass in a solution which came to be known as Schwarzschild's metric. The solution can be used to describe the behavior of slow rotating objects like stars, planets, or those big hunks of meat you see in kebab shops. But Schwarzschild's metric also described something else. Something so bizarre, even the author himself couldn't bring himself to believe it could exist. Black holes. Schwarzschild identified a radius for any given mass known as a Schwarzschild radius, a measurement so small that if any mass were compressed enough to fit inside it, there would be no known force capable of stopping it collapsing into a gravitational singularity. Schwarzschild thought the very idea of a black hole was absurd, despite his own calculations seemingly proving their existence. It wasn't until later, in the 20th century, that black holes would become accepted as real, but long before that, theoretical physicists like Ludwig Flamm were fascinated by these hypothetical cosmic dumpsters. Flamm's investigation of black hole theory led him to discover another solution to Einstein's equations, which Schwarzschild had noticed. An object which worked just like a black hole, but in reverse. A white hole. Whereas black holes trap matter and light and can only be entered from the outside, white holes emit matter and light but cannot be entered from the outside. So how does all that matter and light get in there in the first place? Several solutions to this problem have been suggested, including one theory which asserts that white holes are very old black holes that are in the process of expelling all the material they've consumed over their lifetime. Imagine attending an all-you-can-eat Chinese buffet and spending several billion years gradually accumulating salt and pepper chicken wings inside yourself, but never getting fatter or visiting the bathroom. All that MSG-saturated goodness has been compressed inside your stomach, but eventually something has to give. And when it does, it ain't gonna be pretty. That's when you turn into a white hole, expelling all your internal matter into a quite awful mess on the floor. Ludwig Flamm had an altogether less disgusting theory about the relationship between white and black holes. He theorized that two objects could, in theory, be mathematically connected. White holes are the opposite end of black holes, and the tunnel between them is a one-way street. Einstein himself investigated this possibility in the 1930s, and alongside American-Israeli physicist Nathan Rosen, he came up with a solution known as the Einstein-Rosen Bridge. The object is also known as a Schwarzschild wormhole or a Lorentzian wormhole too, because everybody wants to be the first to slap their name on a fancy new discovery. Did you know that I discovered a now famous blend of alcohol? I named it after myself. But no, it's not what you think. Jack Daniel is my showbiz name. My real name is Jim Beam Red Stag Black Cherry. My parents were jerks. Speaking of jerks, let's get you guys imagining an Einstein-Rosen Bridge so we can get this video done and all move on with our horrible lives. Picture the universe as a piece of paper. If you were to draw two marks at opposite ends of the page, what would be the shortest way to get from one to the other? Draw a straight line? Wrong. Simply fold the paper and smash your pencil through the corresponding dots. Voila! You have shortened your journey by warping space-time, and this is how wormholes work too. Within the context of Einstein's equations, the white hole exit of a wormhole is theorized to exist in the past, with a black hole being present in the future. This implies that traveling through a wormhole would not only take you to another destination in space, but perhaps an entirely new place in time as well. That being said, the very nature of wormholes means they are likely highly unstable and are liable to collapse if even a single particle were to enter them. Various theoretical ways of stabilizing a wormhole using negative matter or cosmic strings have been suggested, but before we can try squeezing ourselves through one, we're going to have to find one of them first. We don't yet know of any physical processes which could create a white hole in the universe as we currently understand it. A gamma-ray burst, known as GRB 060614, was theorized to have come from a white hole, but since it lasted just 102 seconds, we have no way of confirming this for sure. We've never actually directly witnessed an actual white hole. However, we've also never seen a black hole, but we have measured their gravitational effects and proven their existence using mathematical equations. There is one way we might be able to stumble upon a wormhole. A negative mass wormhole may exert negative gravitational force upon the space-time around it, which we could detect through passing light being sent in a concave rather than a convex fashion. We might also be able to locate the gravitational waves given off by two wormholes colliding. This idea was published in Physical Review D in January 2018, and it hinges on the notion that wormholes, unlike black holes, would not possess an event horizon. Now, of course, the event horizon is a region of space-time beyond which nothing can escape the gravitational pull of the black hole. Not light, not matter, not even this guy with his definitely real and totally sweet muscle mass. When two black holes collide, a signal called a ring-down occurs during the final stages. But this signal is quickly dampened and eventually obliterated by their respective event horizons. It's like how movie murderers use a pillow to silence a gunshot to the head. Yeah, this doesn't work in real life. Believe me, I've tried, but the principle is somewhat similar. However, if wormholes do not have an event horizon, as the researchers behind this paper suggest, then the collision of two wormholes should be detectable, since the signals created would echo out through the universe uninterrupted. This is why you should never shoot somebody in a cave or down a well. Now, unlike black hole collisions, we've never actually discovered the signals of two wormholes smashing together out there in the universe. Or have we? The paper's authors speculate that we may have already detected the signals of wormhole collisions without knowing, as our current technology's lack of sensitivity means we might have misidentified such signals as having come from black hole collisions. One of the problems of this theory is that we need wormholes to exist in sufficient numbers to allow them to collide on a regular basis. We have no idea how prevalent these objects are in the universe, let alone how often they run into each other and do that awkward dance people do when they collide on a sidewalk. An alternative wormhole detection method published just a couple of months ago suggests that we should instead look for wormhole shadows, since they would be noticeably different in shape to the silhouette cast by regular black holes. This paper theorizes that any photons of light which move too close to a wormhole could end up falling through it, leaving behind a dark circular void which looks more distorted and squished than the circular disk shadows left by a black hole. This idea only applies to a certain type of rotating wormhole, though. And once more, we don't know how abundant such exotic objects are in the universe. It may be that regular wormholes are quite rare too, especially ones that are large enough for us to see. John Friedman is a physicist at the University of Wisconsin-Milwaukee, and in reviewing the wormhole shadow paper, he stated his belief that wormholes won't be discovered by viewing their shadows, having been quoted as saying, "It's highly unlikely that macroscopic wormholes exist. If they do, the unknown nature of the matter supporting the wormhole makes it impossible to predict the shadow." Speaking of exotic matter, did you know that there's another theory which links the existence of wormholes and white holes to the mysterious substance known as dark matter? Well, we're going to investigate this in our bonus video, White Holes and Dark Matter, which you can watch over at patreon.com/strangemysteries now. For a $2 monthly pledge, you'll gain access to this and over 100 more bonus videos. And you'll also become part of the Strange Mysteries community, where we interact with fans to discuss the topics we want to make and you want to see. Your contributions have a huge impact on our ability to produce mind-bending videos which explore fascinating topics in more depth than ever before. And nowhere is this more evident than in our premium videos, exclusive to our $20 Patreons, where we consult with the scientific community to investigate cutting-edge research before the mainstream media catches on. Here's a trailer for our latest premium video entitled
Chemicals of Reality. Reality, consciousness, brains. What else is there? Ask yourself that question. Perhaps that's all there really is, but perhaps everything else is found within a place where these ideas, these things, overlap. Some thing, some place that is undefinable. To many people, altering certain chemicals in their brains produces what they would simply call hallucinations. In fact, what we're going to discuss specifically used to be called the businessman's trip, as one could enjoy it. Come down and put your pants back on in the time it takes to eat lunch. It wasn't taken seriously, well, unless of course you started digging. And some people, including us, did. Already though, to many people, this chemical is special amongst others. Very special. To them, it represents something more meaningful and incredible, as if it's the gateway to the next level of consciousness. The ticket to a higher reality barely explored by most humans. It is the entry point to a new reality, visited by only a select few, whose minds have become enlightened through the use of this exotic substance. For this reason, it's commonly referred to as the spirit molecule. But is its reputation as a mystical mind-opener deserved? Or is it, and everything it represents, just a load of bullshit? We look at, investigate, and dive deeply into nearly all available research regarding this question, from nearly every angle feasible. And in the course of doing so, stumble upon unexplainable patterns, correlations, and neurological evidence for a reality existing beyond this one. Watch this hour-long Strange Mysteries premium video, Chemicals of Reality, as well as many more to come by becoming an elite premium member of our Patreon at patreon.com/strangemysteries.